Brilliant. So we should be live. Awesome. So what I'll do is I'll just wait a couple of minutes for everyone to log in to make sure the stream's working. But yeah, then I'll get Steve to introduce himself as our data center expert. But thank you everybody who's got tickets for this event. Much appreciated. This is part of the Engineers with Ideas events. So we've got a very special guest, a live stream with Steve Davidson, talking about everything to do with data centers, because I know that's a hot topic in the structural engineering world at the moment. So I'll just wait for everyone to start logging in and then we can crack on.
Sounds good.
There we go. I think people are coming through now. Yep, perfect. Yeah, people are starting to come through now. So I suppose if we just want to kickstart, Steve, if you could just give us a little bit of an introduction about yourself, your background and experience in the data center market.
Yeah, thanks, Dom. So Steve Davidson. I work for a company called Robert Bird Group. We are civil structural engineers at the core, although we have a few other specialisms like construction engineering and geotechnical. Myself, I am a senior director there, and I've been brought in to lead the data center sector, which encompasses the mission critical sector, if you like, as well, Dom. I've got about 12 years experience working in and around the data center market, and it's gone from them being, for me, very large sheds, single story, somewhere in the sticks that no one knew what a data center was, to the hot topic, as you said, and across the industry right now. So yeah, great to be on, and look forward to talking more with you.
Okay, brilliant. So just to kind of run through the topics that we'll be going through, I think Steve's may have paused his video there, but just to let you know, we can't share any of the images of the projects, obviously, because there's a lot of NDA there as well, so don't mind Steve's image. But just to go through the topics that we'll be covering, we'll go through them in detail each. So it's going to be, first of all, heavy floor loads and floor performance, then speed, scalability, and repeatability, then the MEP coordination, and then finally talking about the fire and resilience as well. So I suppose, Steve, just from your perspective, if you could just talk us or kickstart things with heavy loads and floor performance, particularly when it comes to the intense loading demands of server halls and any kind of vibration performance that we know is critical for the data centers. If you could just shed some light on that topic, if you could.
Yeah, quite a broad topic to sort of respond on, I guess. But yes, the load requirements for data centers has been increasing over the years. Initially it used to be around the 10 kilonewton per meter squared, kilopascals, whatever units you want to work in. But we're now up to 15 and beyond for the higher density racks that are coming in, the new liquid cooling requirements that are there for these higher performing racks. So obviously this presents a challenge, because traditionally, from a structural engineer perspective, data centers arguably weren't the most challenging engineering feat out there for us. But what we're seeing now is the real challenge coming into the market, just to stay on loads for a second, is what we do with legacy data centers. So you've got data centers that sit on prime land with good connectivity, huge amounts of power, but they're actually maybe not up to current requirements. So um, you need the structural engineer to come in and see what we can do. And there are a few clients of ours right now that are asking us that question: what can be done with the existing DC? Because a lot of the time the data center is split down, much like a mixed use commercial unit. You've got multi-tenant space, so they don't all align to move out at one time. So what can we do with the existing space? Can it be improved up to that higher load? But that is becoming even more common in new build as well. I mean, we've got some jobs we were chatting earlier, Dom. We've got jobs on site right now that, because they were designed, 18 months ago, perhaps, they are no longer fit for purpose. But piles are in the ground, or are slabs in the ground, and we've got to suddenly produce a DC that has got much higher floor capacity requirements, but we've got foundations in, so you need to start thinking quite laterally, and that's a proper engineering challenge for us, which is where we play best. And I would say that we are being brought in on a lot of these jobs as a replacement engineer to make these improvements, because it is quite an engineering feat to find. Some of these DCs are 7 stories plus, and when you've gone from 12 to 15 kPa, it's a significant. You're talking what, 20% increase on every floor, and those piles need to take that load. So what can we do? Vibration, obviously, you mentioned that it used to be quite a critical, or a very critical issue, because if it was an old disk type server, they were a bit more sensitive to vibration. A lot of the new kit is becoming less sensitive, but we still need to make sure that we meet the criteria requirement of the incoming tenant. But there's so many ways of doing it, whether it's damping the floor with a heavier use, or isolation feet at the source to try and get rid of it. But I guess it's thinking, I don't know if, Dom, I think you and I are old enough to remember Sony Walkmans that came with built-in damping. It's that kind of thing. It's making sure that when you're going for a jog, your music kept playing. So I guess that's what we're doing in simple terms, I guess.
I was just wondering as well, I know you were saying about, a project 18 months ago, not kind of being in line with perhaps regulations now, but what has changed from that data center being absolutely fine 18 months ago to now? What's changed in terms of regulations or the way things are done?
It's not regulation. It's more the incoming tenant requirements. Because of the higher density racks, the increased loading requirement for the cooling system that's been implemented, because of it's much more intense kit running a much higher voltage, and providing more wattage in terms of your IT storage. They suddenly, it's like an agent coming to you and saying, my in a commercial space, my tenant doesn't want 4, they want 8. Well, maybe not double, but it's certainly a significant increase. So it's more to do with the advances in the IT equipment that's coming in, the server racks themselves.
Okay.
They are more power hungry, but then they are more dense, they're heavier, they need more cooling, and that results in a much heavier floor load.
So what's the typical kind of design solution then to get over that problem?
We are trying to put some more lateral thinking into it, whereby we say, we challenge the brief and say, do we actually need 15? Because when you take the floor plate, it may not be 15, it may be a much lower number. But ultimately, it is going for a lighter solution, stiffer solution that provides the increased load, especially, but more complex when it's an existing system that needs to be adapted. So it's fundamentally just big engineering, finding a different solution to provide something that is the same weight but will provide the higher load requirement.
Okay, interesting. So it's less about regulation changes and more about kind of the clients and the changes in the technology and the servers.
The equipment that's coming in that is changing. Yeah.
Okay, brilliant. And then something that I was quite keen to kind of go over when we're talking about scalability and repeatability, because I know obviously how tight the programs can be with this. I know we chatted briefly on the modular side of things as well. So I suppose, first of all, could you give us an idea about, how rapid the programs are, how you kind of make sure that you're sticking to those, particularly when it comes to, the big name clients that need things done on time or if not earlier?
Yeah, I mean the timescales are rapid. You know, you're talking stage two tends to be anything from 8 to 12 weeks, which when you're almost starting from scratch is quite a quick turnaround, given the numbers that you're looking in terms of construction value for the shell and core, which is where we add the value. But there is so much repetition in the design, I guess, that allows for some efficiency in the time that it takes to design and coordinate. Um, and going on to the modular side, there is definite advantages to it. I mean, right now, a lot of the racks come in modular. Some of the hot and cold aisle containment comes in modular skids into the primary frame, which is why we need some uh, fairly high tolerance and flatness so that we can get this kit in. That's just one of the reasons for the flatness requirement. But what we're also seeing now is what we used to call or still call the grey space. So you've got the white space, which is the server racks, the money maker. The grey space was the sort of server rooms and backup power or UPS, to make sure that you've got the two levels of backup power supply if an event of the grid going down. They used to be housed in what we're calling grey space, which was enclosed space, wind and watertight, and then fitted out. But you've got things like ePods that are being delivered. I know them as ePods anyway, being delivered to site in modular units. So it'll be a switch room with UPS. They may come as one, they may come in sections, but they're effectively plug and play. They're bolted in. But my frustration as a structural engineer is that these items come in with their own modular structure, but they are landed and pulled into a primary steel frame structure. So you've already got a structure on site, and then you pull in this module to it. And I understand it's fully down to supply chain. They've designed a module that is fit for the purpose it was intended for at the time. But we are sort of saying, well, why can't we actually bring in the actual frame to the module itself and then stack it as you would expect for any modular type system? Look at residential, you've got effectively the shipping container effect where you just
Mhm.
stack them up and it could still be plug and play. So it is something that we've been speaking recently to manufacturer of ePods and of course generators, because it's the same question to either. Some of it comes down to lifting requirements, loadings, because these are heavy bits of kit. But there are products out there, and there are crane manufacturers that we're also bringing into the conversation. So I could definitely see an improvement in the speed of delivery, the scalability of this, and then, as you said, it's the speed, scalability, repetition. It's all answered in a way. Um, we have discussed how we could do it with the white space, but I think it becomes quite complex because you're always on the race to the roof with the white space. So if you're delivering modules with the server racks in it, you're stacking them and they're not enclosed or window watertight. Very, very expensive pieces of kit to be left exposed. I don't think it's the correct solution, from my personal opinion.
Mhm.
There, willing to be proved wrong on that, but definitely with the um, backup power and switch rooms, these ePods and the gen sets could be modularized and definitely provide a lot of advantage to program. But that's on, I guess, more the colo side of things. Then you've got um, the hyperscalers, which they typically have their own template design. So you could pretty much look at a design anywhere in the globe, and you would know which hyperscaler had delivered which, and that tends to come as a kit of parts in my mind, which is another way of, I guess, making it quite a modular way of delivery. Improves buildability, speed, but I think they could also benefit from this backup power use of modular supply. But it does need the supply chain to probably adapt their factories and their equipment to make sure they could deliver what's required.
I was just thinking then, just on the theme of modular as well. I know, the kind of whole sustainability agenda within the data center market can be a bit of a tricky topic, because a lot of people are not too sure what sustainability principles or techniques they can use within that sector. They're not sure what the parameters are to be able to use it. So I was just wondering, kind of expanding on the modular side of things, which is obviously sustainability based. Could you expand on any other processes or any other kind of specific topics that people can at least start thinking about to increase sustainability on data centers?
I mean, a lot of it's been talked about already. It's the heat recovery, or the reuse of the heat in district heating systems. I guess the difficulty we have in the UK is, unlike you take the Nordics, for example, they already have district heating systems running through their towns and cities. Whereas it would take a huge amount of investment to provide the infrastructure, because it is effectively a large heating network of pipes that have been installed in years gone by. So it works there, but you are seeing some projects now, including in London. There is one where they are utilizing the heat. They've got an energy center attached to the data center, which then feeds into a new housing scheme that is being developed in the same planning application as the data center. So that obviously has massive positive implications in terms of sustainability, because you're utilizing not all but a good percentage of that heat waste. So that is one thing. Going back to the question on modularity, it will always improve efficiency, but it does come down to where the material's sourced, where the factory is, how easy it is to get the modules to site, because if you've got difficulty in transportation. So it's very much site specific, as it is with any project. But I think the biggest thing, or the biggest challenge right now, is going back to my first point of legacy data centers.
Mm-hmm.
I always believe uh, you should look at the existing building that is on the site before you go knock it down and reuse it. I'm not saying the best building is already there, but there's definitely something you could do with it. And let's make sure that we try our best to utilize the embodied carbon that's been expelled building that original facility. And if it can be adapted, let's try and maximize what it can do.
Brilliant. I love that. Really, I like the idea of the excess heat being used for the residential development. That's something I've never even thought of before, but yeah, I love that. Okay, so kind of moving on to the next topic, and this is, remember I had a guest on the podcast, the Building Your Career podcast from Phoenix ME.
Yep.
He was one of the directors there that talked a lot about the MEP side, from a data center perspective. And to be fair, a lot of it went over my head, but I just wanted to, because and I know it's such a big part, a large part of data centers. Could you talk us through, obviously, the MEP side and how structural engineers should, what they have to know about, and how they need to communicate with their M&E teams as well?
Yeah, well, I mean, first and foremost, in data centers, M&E is king, or queen for that matter. They kind of call the shots in terms of when you're developing out. The money maker is the kit that's going in there. So traditionally, I used to say, as civil and structural engineers, we needed to get in and get out the way of everybody. But it does call for, as sometimes it's the afterthought of, well, this is what we want the data center to be. You guys just build your frame around it. But it is fair enough. And when you're working, you've got these massive rigid systems that just, space and time is the key of delivery. So if we can understand what the mechanical electrical engineering challenge is, we can then start to work our structural design and indeed our civil design around it, because you can't forget the amount of pipes, cables that are coming through the ground. So we need to make sure our drainage system, our foundations are all coordinated, to make sure that it's out of the way of the big kit coming in. Um, and then once you get out of the ground, in terms of the grid, it's just making sure you think cleverly with M&E and architecture where the corridors go. Do you do twin corridors? And that gives you future adaptability. You need to look at your zoning of your plant locations, distribution of pipe work, duct work, all of that, and make sure the most efficient grid you can come up with works. You allow for suitable penetrations that are pre-cut in the frame for future adaptability when it's pipework running away from the run of the main grid. Um, and then not just the design working, but how the hell we build the thing. And I guess this still comes back to that point of the modularity and the backup side of things. A lot of the time it's a bit of a pig's ear to land these modules or land the kit into a frame that's already on site. So, that's why we start to think about these modules. How could we drop them in? How could we make it easier to plug and play? Um, and you've also then got to think, as on top of buildability, the adaptability, access, and maintenance. So, where are the breakout panels? Should we ever need to get the kit in and out? We've not slapped a big old brace bay where a generator needs to come out, or these kind of things. So, I mean, they're fairly straightforward challenges when you look at them on the face of it, but it all has to be thought about at day one. But I think the big thing, coming back to what the first point we made about, there's DCs right now that are no longer fit for purpose and they need to be adapted. How can we make build-in redundancy? How can we make them as adaptable as possible? And I guess moving away from the hyperscalers who have their fairly set template design, you've got colo designers that they don't maybe know who the tenant may be coming in. So they need to have an air of flexibility. So what's the best material for that? What's the best grid for that? To make sure that should anything change with the incoming tenant contract, it can be quite quickly switched around and worked for someone else.
Awesome. I was just thinking as well, is there any particular examples that you can give of M&E challenges that you've had in the past before, and kind of what the design solution was behind those challenges?
Oh yeah, a few. From a simple thing as the ceiling that was installed was a typical ceiling. They were running the cables in through the cable gantry system, but they hadn't factored in the size of the cable. And when they were pulling it, it effectively ripped down the whole ceiling because the ceiling wasn't up to the kit, because such are the size of the cables that are being run in the buildings. Up to fitting out, I say fitting out, it was a large scale fit out of an existing data center that was about 10 years old. Um, there was no real thought put to other than, yeah, we can, that hall is a data hall. We can fit it out with what we want. And we suddenly had to remind them that the roof was not designed for the loading requirement that was needed. And we had to install 20-meter trusses that, I forget the overall tonnage, but it was a box within a box design that we did to make sure that it didn't impact existing foundation loadings and a few other bits and bobs. Not to get too technical, but there are real engineering challenges in there that are often overseen, because you think it's a data hall, or a data center, it'll be able to do what we need it to do. But more often than not, we end up getting a phone call to to try and help solve the solution, or
Um,
provide the solution, so to say.
and I suppose I was quite interested in the process when it comes to when the M&E team gets involved, what the kind of the communication should be like with them. If it is heavily M&E led with these projects, typically when do you find the communication starts, and how do you maintain best communication throughout the entire project lifecycle?
I think it's well, it's, stage one, everyone's thinking about it, but you're more looking at unlocking the site, making sure you get the power. Um, Once that's all locked in, you actually get into the fun design, which is stage two, and that's where M&E will probably take lead, um, or act as lead designer, if you like. Um, but it is down to the relationships. It's quite a small world, the data center network, in terms of the consultants. And I think, generally, in my experience, everyone works well together, and there's a common understanding that these data centers are very expensive facilities, um, and when a lease is signed, there tends to be a finishing date, and that finishing date can't be missed because the extension of times can get very expensive when you look at what a megawatt of data provides in terms of income and rent. So it's in everyone's interest to pull together, work, understand, and that doesn't just go from M&E to structural engineer to architect. It also goes to quite often you have the team novated over to the contractor to deliver the job, and the client will then employ a managing team or a client monitoring team, um, to make sure that the design is being implemented as it should be. And the coordination and collaboration that you get with those other engineers, albeit in the same field as you, is quite refreshing, because everyone knows that you're not out to, and I'm not saying this is the case in the industry, but we're not out to get each other. We're there to support each other. And if they support us in the client monitoring service, if we've missed something, they know that we're going to scratch their back the next time. So there's a proper community spirit, which is very refreshing, as a sector, I must say.
I was quite interested to hear as well, because I know from my perspective anyway, I always imagine data centers to be these absolutely huge mammoth projects. But I just wanted to get from your perspective, because I'm thinking about the M&E and how vast that can be. From your perspective, what are the kind of the size ranges of projects, and do they go down to just super small, or is it all just absolutely huge data centers that is the main thing?
I mean, yes, we just got asked to look at something that was a 2 megawatt fit out of an existing hall. Um, so that it's funny to think now that 2 megawatt is so small, because only a few years back 2 megawatt was a fairly big data center. But we're looking at sites that are a gigawatt.
Mhm.
So you're not talking about a couple of sheds. You're looking at a small town's worth of data center. So the infrastructure alone in that project, the civil engineering involved, the reworking the land, um, is huge feats of engineering for us, um, before the cabling even gets pulled in there. So
Mhm.
and then a lot of the time the sites are, redundant power stations or old factories, so they tend to come with their challenges of what was in the ground historically. So we're having to solve the challenge of how you get the site remediated and the new structure out, or utilize existing structure, which is always nice to do if you can. Um,
And because I was just thinking as well, because you mentioned that you'd worked in like a 7-story data center before, and again, I was under the assumption that they were mainly kind of steel portal sheds. But how common is multi-story data centers, and why would they be multi-story as opposed to a large steel portal frame shed?
All comes down to location.
Okay.
Much like your houses, it's location, location, location. If it's in the an urban environment, land is not as cheap. There may be high amounts of power. So the only way to utilize that power and connectivity is to build upwards. Whereas if you're out in the uh, less urban environment, um, you have more land to utilize, I guess. So it's obviously the less you need to go up, the cheaper it is to build. Um, so you do have to weigh it up, but yes, it's typically dependent on where the data center is and how tight the site needs to be. But then you'll go as tall as the power allows it to be honest.
Okay. Okay. Got you. What's been the tallest that you've ever come across?
Currently looking at a 20-story.
Wow. Wow. Okay. Didn't expect you to say that. I thought you'd say 10 max. But okay. So just to kind of round things off and move on to our kind of final topic with the fire and resilience in data centers, could you shed a little bit of light on what the structural engineers kind of input on that is really, or who the main people are that you would have to be communicating with when it comes to fire?
Yeah, I mean, for obvious reasons, and I think everyone's aware of it, fire has become a topic of its own right within the design of any building. So we have specific fire engineers that will join the team and lead that side of the design. They're often attached to the M&E designer or the architect, and they will effectively specify the the requirement, the solution that we're looking to go for, and then we will design to suit. But I guess the thing that I hadn't thought about before is that you typically think of fire as being you're designing for a time to get everyone out of the building, and that is my normal brain thought with any fire design. But with data centers, it's you don't just think about that because obviously that is important. But these aren't very heavily manned buildings. It's also about uptime. So how long can you keep the data center alive to transfer information? So that is probably the most critical. Not to put human life under it, but
Mhm.
that you are sort of transporting very expensive or very important data. So it's asset life safety, but also uptime, which needs to be thought about. But it's all the typical fire requirements for us. And I guess all we do is design for the water tank if there's fire suppression, which obviously isn't great in a DC environment. Um, but it's then onto the actual frame itself and how long we can keep it up for to allow the kit to do its job and transfer the information, I guess. And then in terms of we were talking about blast as well. That isn't something that comes up in all data centers, but it is becoming increasingly part of the conversation when you think about, government information or defense. Obviously, you don't want that to be uh, show any weakness to blast requirements. So that comes with its other own challenges, and there's a whole different coding to it. But there isn't a hard and fast, but you tend to follow um, the design for sort of military systems for that. So that's where the sort of civil structural portion of it comes in. So I'm no expert in fire. Will never claim to be either. I leave it to the experts. But it is a very interesting topic, and yeah, we can implement different things from a civil structural point of view to make sure that we suitably design for it.
Awesome. And then just final question for me as well. I was quite interested in where you see the kind of the future of the data center market from a structural engineering perspective. Is there any kind of innovations that are ongoing at the moment, or any kind of new ways of doing things that are on the horizon that perhaps the technology just isn't there yet?
Well, I guess the modularity of pods is one of them, and I've already covered that. Um, but as we talk about driverless cars, as we talk about um, Amazon dropping off with our drones the parcels into central distribution center, whatever it may be, you need wider spread, what they call edge data centers, um, and these are small remote data center offerings that could be 1-2 megawatt, but um, this is Stephen Davidson talking. I don't have any facts to back it up, but I can see a day where much like with a planning application, you may have to provide a substation within your mixed use commercial building. You will actually have to, by planning requirement, provide an amount of data center offering, which is not for the building, which is solely for a district network. Um, so yeah, that's something that I can see coming, and having well, I don't just work in data center. I cover many sectors, but mixed use, cut and carve, and commercial is another one of the sectors that I work in, and I can see that coming in there. So it's interesting to have the conversations already with some of the um, typical developers in that sector, and hear that they are interested in having that. So
Yeah, it's becoming more and more, speaking to developers and main contractors, it's becoming more and more of a topic in terms of at least having a set amount of land for the data center.
we're so short of the demand right now. Yes, we've had a little blip recently. I don't think I need to go into detail as to why, and I can't go into detail as to why, probably. But yeah, it's just been a minor blip, and the busy period will be coming soon again. And yeah, we are so short of the demand right now that I think it's wise for those that aren't already in it to be getting into it. Because I hear some people saying it's too late, but I don't think it is. I think it's going to be a busy sector for at least the next five plus years.
I agree. I completely agree. And I just want to say thank you so much for coming on, Steve. It's been a fascinating topic. I've certainly learned a lot, and I hope our listeners have learned a lot too. So yeah, just goes to say thank you so much for taking the time to speak to everyone.
No problem. I'm glad my voice stayed up for us.
Brilliant. All right, Steve. Well, thank you so much for your time.
Thank you very much for having me on. I hope it was useful.
No probs.
Brilliant.